So ligand can make one bond with the central metal ion or one coordination bond with the central metal ion. So such kinds of the ligands are called as monodentate ligand. Monodentate ligand. Which of the following is a monodentate ligand, they may ask you. Monodentate ligand is the one which has only one lone pair of electron, or not, the one coordinating atom. I mean the one coordinating atom is there. For example, ammonia. Ammonia here, all the ligands whatever mentioned here are monodentate ligand. That is, ammonia is a monodentate ligand because through the nitrogen, only the nitrogen is the donor atom. So only one donating atom will be having. What happens is, nitrogen will establish a coordination bond with the central metal ion from ammonia side. So this is the bonding which happens. For example, water. Water is also a monodentate ligand because only one donating atom you are having, that is, it donates a lone pair of electron to the central metal ion. That is, only one bond will be established from the water side. Same is the case, cyanide ion also a monodentate ligand, Cl minus also monodentate. All halide ions, Cl minus, Br minus, I minus, F minus, all are monodentate ligand, carbonyl ligand. Right. So, the ethylene, the pyridine is the ligand. Pyridine is also a monodentate ligand. Pyridine, OH minus, right? All are monodentate ligand. These are the example, and many more we are having monodentate ligands. I'll repeat again, what is a monodentate ligand? Monodentate ligand is having only one coordinating atom which will be giving to the central metal ion. So all these things, for example, Cl minus, Cl is the coordinating. Carbonyl CO is also a monodentate ligand. Also it can be called as a ambidentate ligand. We'll just take a look at that. Okay, so we have SCN minus, this is also a monodentate ligand, right? So all are monodentate. CH3CO minus, acetate ion, CH3CO minus, O2 minus, all these things are monodentate ligand. So ligands can be classified into various classes. One way to classify the ligand is how many coordinating atoms will be there in the ligand. If it is only one coordinating atom, or it can able to establish only one coordination bond with the central metal ion, then it is called as a monodentate ligand. If it can able to establish two coordinate bond with the central metal ion, how do you call this? This can be called as bidentate ligand. This can be referred as bidentate ligand, right? Bidentate ligand means it will be having two coordinating atoms, or it will make two bonds with a ligand can able to establish two bonds with the central metal ion. They may ask you examples for which of the following represents a bidentate ligand. So for example, ethylene diamine, ethylene diamine, that is, you have CH2, NH2. So ethylene diamine could be the example for the bidentate ligand, right? So there are two ligating atoms are there. How many ligating atoms will be there in a bidentate ligand? There are two ligating atoms. Take a look here. This nitrogen can establish a coordination bond with the central metal ion. This also can establish a coordination bond with the central metal ion. That means one ligand can establish two bonds, two coordination bond with the central metal ion. That is what is called as a bidentate ligand. Glycine also an example, right? Glycine. Right? CH2. CO minus NH2. So in the glycine case also, you can have this can establish a coordination bond, this can also establish a coordination bond, right? So there are many more. Oxalate ion also example, that is CO minus, this is also an example, right? Because it can link through the oxygen, or else it can link through two oxygen. I mean, two oxygen atoms can give the lone pair of electron to the central metal ion. So one ligand can establish two bonds. That is what is called as a bidentate ligand. Similarly, we have number of the cases, that is we have tridentate ligand. Tridentate ligand means, students, what does it mean? It means that it can establish, one ligand can establish three bonds, or there are three coordinating atoms. So we have tridentate ligand. Tridentate ligand we can have. Tridentate ligand same can be derived, right? CH2, NH, right? Again CH2, NH2, right? This is anyhow NH2. How many nitrogen atoms we have? 3 nitrogen atoms. That means it can make 3 bonds with the central metal ion. That is, it is a tridentate ligand. That means dimethylene triamine. This is ethylene diamine, right? Ethylene diamine. This is dimethylene triamine, right? Diethylene triamine. Diethylene triamine it is. Diethylene triamine. Diethylene. This is an example. So same way you can have the tridentate ligand, tetradentate ligand also you can have. Tetradentate ligand. Tetradentate ligand, for example, what can be done here is, for example, CH2 NH2, right? CH2 NH2. This is ethylene diamine, right? So both the hydrogen can be replaced by CH2COO minus and CH2COO minus, right? That is ethylene diamine diacetate. Ethylene diamine it is, right? Ethylene diamine only. Ethylene diamine diacetate ions are there. Diamine diacetate. So this is the ligand we have. How many coordinating bonds it can establish, or how many coordinating atoms it has. So this oxygen can link to the central metal ion. This oxygen also can establish. This nitrogen can establish 1, 2, 3, 4. That is, it is a tetradentate ligand. It is a tetradentate ligand. Similarly, we can have, students, pentadentate ligand we can have. Pentadentate ligand we can have. Pentadentate ligand we can have. In the pentadentate ligand, same thing I will be taking, that is CH2 ethylene diamine. I will take it as a basic one, NH, right? N CH2COO minus, CH2COO minus. Here one of the hydrogen I will be replacing by CH2COO minus. Try to understand. In this case, what we have done is 2 nitrogen atom and 3 oxygen atom can coordinate to the central metal ion. That means there are 5 bonds can be made by a single ligand. That is why we call it as a pentadentate ligand. The last one is we have hexadentate ligand, which is a quite famous ligand. Hexadentate ligand. Hexadentate ligand. Hexadentate ligand. That means it can have, one ligand can establish 6 coordination bonds with the central metal ion. One of the hydrogen, this hydrogen whatever left out also will replace by acetate ion, turning out to be CH2, right? N CH2COO minus, CH2COO minus, again N CH2COO minus and CH2COO minus. That means totally we will be having 4 oxygen atoms which can coordinate to the central metal ion, and 2 nitrogen lone pair also can give it to the central metal ion. That means it can establish 6 coordination bonds with the central metal ion. 6 coordination bonds. So how do you name this? Ethylene diamine tetraacetate. This is ethylene diamine triacetate, ethylene diamine diacetate. Ethylene diamine triacetate is a pentadentate ligand. Ethylene diamine tetraacetate. ethylene diamine tetraacetate. Ligand is an example for the hexadentate ligand, very famous one, very important. They may ask you what kind of the ligand ethylene diamine tetraacetate is. It's a hexadentate ligand, so it's very important. It makes a very strong complex with the metal ions such as magnesium, calcium and all. Hence this is used for the detection of calcium plus 2 and magnesium plus 2, or quantitative analysis of magnesium plus 2 and calcium plus 2 will be done by using the ethylene diamine tetraacetate ligand in the laboratory. Okay. So this is about the ligand. So one more ligand is also there, that is